Yeah, hello, can everybody hear me okay? Let me know if any problems. Yeah, so I'm Tom Lehman, I'm with ESnet, and we have a panel today, and we're gonna talk about the SmartNICs is kind of the main focus, but as you can tell by the title, it's a little bit broader than that. We're tying in some other things like some of the network automation and orchestration and edge systems. So the reason we're doing this is that there's been a lot of work ongoing in the R&E community for a lot of network automation and orchestration, and the Sense project is an example of that for people who are familiar with that, where we have a lot of power and ability to work with the R&E networks today and do a bunch of provisioning. And now we've been collaborating over several years now with the National Research Platform, and that's an example of a very powerful set of distributed edge resources, which we're very focused on integrating the edge site resources like NRP into the networking systems. And then when you start getting the edge site resources like NRP integrated, then you're also integrating all the workflows and application sciences that are on top of that. So what we want to do today is we're going to talk a little bit about those aspects of it, the integration of networking and the powerful edge systems like NRP. But the SmartNICs is going to be a focus because that is really where we see an emerging technology that allows us to glue all this together, the network services, the edge site resources, the application workflows, in a lot of different interesting ways. And there's a lot of different technologies when we talk about SmartNICs and functionalities. So we have some panelists here, and we're gonna let them talk about kind of the things that they see in this space. And the idea is to kind of just review, like, where are we now? What's out there now? What do we see for the future of this whole integration of networking, edge site resources, application workflows, and what is the role of SmartNICs and what value can they provide? So what I'm going to do is I'm going to allow each of the panelists to come up here, and they're going to give a couple of slides and just kind of give their perspective on where we are, and then we'll have a question and answer session afterwards. And I'll let each of the panelists introduce themselves and not take more time. And I don't know if Harvey is online yet. Can any? Okay. Should we go ahead and just keep going, or do you want to? Okay. So we'll keep going. Harvey will catch up. So I think the first.
I'm there.
Oh, hey, Harvey.
Hi.
Good. Okay. Sorry, I just give you an introduction. So I think you know this. So we're just going to go into the panelist presentations. So the order will be Justas, Joe, Harvey, and then Mohammad. And I'll let each panelist introduce himself. So Justas, you want to go next? And I'll switch to the full screen here. Can we see the slides? Let's see. So we can get the slides on the main screen would be good. There you go.
Okay. Thank you, Tom. So, hi, everyone. My name is Justas Balcas. I'm the software engineer at ESnet. One of the projects where I am involved at ESnet is called Sense. So what Sense pretty much does, it gathers all the information from all the sites, all the network providers, and just provides one big kind of model where you can easily go to Sense and say, I want a path between UCSD and Hawaii. Just give me the path and do the job. I'm mainly focusing on the resource managers, which is kind of solving the last mile issue at the sites. So I have to deal with different network devices, different clusters, Kubernetes, Docker, bare metal, how to do VLAN configuration or different operating systems. So where we are right now, focusing on NRP, we have it deployed on 15 of the nodes. We are covering multiple network domains. And pretty much if you look on the resource manager, it's easily adaptable to any different network research education network, or even a site. You can use Ansible, you can use CLI, you can use RESTconf, or even if you use Oscars or something else. So using that, we can easily control the VLAN, BGP, IP assignments. From the client point, it's everything intent-based. So what you do is you mainly just say, can you give me a path between Caltech and UCSD? What's the maximum possible between Caltech and UCSD? Is there any allocations which are taking the resources right now? Mohammad will cover more on the NRP Kubernetes operator and what he's doing with it and how he's using, so I will not go into the details. But I would like to go on one of the interesting ideas. What we did is what we are doing on NRP for LHC and use case for retransferring through the Sense the elephant flow, so whenever you have the big flows. So before trying this on LHC through D, first of all, we just wanted to know what we can really achieve from the software itself. By using NRP, deploying 2 X3Ds on 2 Gen 5 machines, Together with Sense, we created loops going through ESnet and FABRIC and also CERN, where you can manipulate different round-trip times and also change CPU memory requirements, MTU, TXQ length, and see how your software is really performing and what is really needed for you to achieve 400 gigs. Now, another step what we started to look is what we can do where we have no network control. So we need some smart NICs. So NRP deployed one of the nodes at CERN where we are using VPP together with FRR and DPDK. What we can do, we can run all the software control at the server itself. So you don't need control on the network, so you can do everything on the server itself, even on the Kubernetes cluster. We already see like 40% lower latency compared to the kernel routing, and we can run everything pretty much in the containers. One thing what we want to look, and it's also not available yet on NRP, is on the Bluefield 3, so that we can move everything and run just pretty much all the software router, DPDK, VPP on the NIC itself. Now, moving forward, we are looking to add all the Internet 2, NiceRNet, and MGHPCC NRP nodes, and we're already working with them. If you're planning to come of any of these conferences, we have multiple demonstrations which are going to cover what we do on NRP with FABRIC, UCSD, and ESnet together. In the end, my dream is to have a coverage on the most NRNs as possible. And if you connect AI together, where you have network control and the full visibility, you can kind of predict and also reroute the traffic if you have utilized link, which is already pretty much too much used, and reroute to another link which is not used. I think with that, thank you. I will give it to next.
So the theme here is SmartNICs, so I'm going to put them in some context. One of the areas we're involved in is creating high-capacity WAN links end-to-end across thousands of miles. That's 400 gigabits, 800 gigabits, and 1.2 terabits for thousands of miles. And that requires a variety of different components. One is something we have put a lot of effort into, which is customized DTNs, data transfer nodes, which consist of customized hardware, customized software, and the interaction between the DTNs on both sides. SmartNICs are a key component because increasingly we're placing the logic of the network inside those SmartNICs. Also, I'll mention, it's not part of this, but we're doing some interesting work with FPGAs. There are some people that take FPGAs to do high-fidelity looks into network traffic and then do analytics after the fact. We're doing some real-time provisioning with regard to deep fidelity views into the network. So basically what this looks like is for our 1.2 terabit service, which we have on two 1.2 terabit test beds between our Starlight software-defined networking facility in Chicago and a joint big data test bed in McLean, Virginia, which we run with the Naval Research Lab in the NASA Goddard Space Flight Center. This is what it looks like. You have these customized 400 gig Gen 5 DTNs on either side, going into deep buffer switches, going into high-performance transponders. A key component are these SmartNICs because they do control the flows and the orchestration among the different resources. However, increasingly, we're also using the SmartNICs to place workflows directly as part of the pipeline for compute, as opposed to taking data for the workflows outside the network, putting it in a server, and then plugging it back in, which is the current traditional model. And there's a couple of nice projects that we're working on with this. Two are in partnership with ESnet Labs. One is called SciStream, which is pipelining data from the advanced photon source to supercomputing memory. Another one is a gamma ray analytics project called Greta, which is being done in being led by the energy science testbed. But both these are really nice examples of doing high efficiencies using just the processors in the net, including SmartNICs. And I'll point out that these are getting more and more sophisticated. They're getting more memory. They're getting better processors. Soon you're going to have basically a supercomputer as a SmartNIC with which you can do anything you want. So with that, I'll turn it over to the next speaker.
So next is going to be Harvey, and I'm Harvey. I'm going to flip through the slides. Hopefully you have a local copy, and you can let me know what slide I should be on, and hopefully Harvey can still hear us. Harvey, you still there?
Yes, I can. I was seeing the slides rather well. Can you go to that mode again?
So I'm on right now. I'm on your first slide, Harvey. I don't know.
Hey, that's great. Let
Okay.
me take it over.
Okay.
So, I mean, you started to hear from Justas and from Joe about some of the tools and projects. And I'd like to very briefly kind of give the big picture and then some of the details of the infrastructure with a focus on California. So the Global Network Advancement Group was formed in 2019 to enable the community to make best use of the world's research and education networks. In 2020, there were two key working groups formed. Tom already referred to one, which is the AutoGOLE Sense Working Group, and Justas said more about that, which is great. The Data Intensive Sciences Working Group was formed in order to meet the challenges of the greatest or largest data-intensive science programs, starting with the Large Hadron Collider, but not only. Some are shown here. But at the same time, as we enable the community through all the tools that you saw and through intelligent control and operation of next generation research and education networks, to do it in a way which is compatible with the needs of the larger academic and research community, which depend upon the world's R&D networks. Next slide. So the system concept is a sort of the overriding concept, which includes pervasive monitoring, intelligence, the ability to make intelligent decisions about the use of the available network resources. I mean, to load balance, to take into account policy, priority, network state, site state, deal with different projects and try to satisfy through machine learning and eventually concepts which include some game theory concepts, to really satisfy the community, meet their needs, and yet work as friendly partners with the world's R&D networks. Next one. So this shows the infrastructure which was fielded. This is from SC24, but much of it, except for the links that go to Atlanta, which of course have been taken down now, this remains. And between CERN, Internet 2, ESnet, we have this magnificent infrastructure working together with Starlight and also the others to do this at scale. And so the other major theme, apart from a new, very impactful type of global system, is to do this at scale, both to make good use of the current generation and upcoming generation of R&D networks, as Joe mentioned, on the 400 to 800 gig scale, and to learn and track current technologies, and to craft the way in which science programs look at their requirements, both realizing the opportunities of those technologies, but also projecting forward and trying to imagine what the real environment and real opportunities, not only for intelligent network operations, but ultimately for improved discovery reach of those programs, what those opportunities are. So this shows a cartoon about the scenic pop in LA and some of the links to the Caltech campus, supported by equipment loaned to us by Sienna, with a 1.6 terabit a second link between the campus and the scenic pop, and 4x400 links on the campus. If you go to the next one, you can see another view where, apart from the 4 links that went off to Atlanta, we still have this infrastructure. And you can see the links to Caltech campus, 4x400, and a somewhat older 4x100. And also towards the bottom, UCSB, which we understand will soon be upgraded to 400, and we've been discussing 800 gig links. Next one. So this is what's on the campus. And our production data transfer nodes, there were 6 remaining during SC24 and 2 at SC24. Now we have 8 of them. And the 8 shown here, each of which has a 400 gig connection, 200 gig connections in addition, is more than capable of matching that infrastructure. And final one. This is just a snapshot of one of our data transfer nodes. We did verify that it's capable of more than a terabit a second. With FTT, the software, which has evolved since 2006 based on TCP, we can support 400 gig flows, 560 gigabits bidirectionally. And so the opportunity exists in terms of the hardware to actually operate this intelligent infrastructure at scale. So we're just at the beginning, but there's a great and bright future if we execute and follow up on this vision. Thanks.
Thank you, Harvey. So we'll go to the next presenter, which is Mohammad.
Hi, everyone. I don't want to talk your ears off today. It's just in terms of SmartNICs, in the context of Nautilus, we have to define what resources are available, what can be used as SmartNICs that is currently available on Nautilus. And like we mentioned, we have mentioned the Stratix FPGAs. Each one is 6 times 100 gigabit per second. That can be used as a SmartNIC. We have the 32 Xilinx Alveo U55C FPGAs. Each one of them is 2 times 100 gigabits per second. Both of these sets of FPGAs, they're behind Tofino programmable, P4 programmable Tofino switches. So they're behind EdgeCore 400 gig switches. So the switches themselves are also programmable. They provide sort of a programmable element into the network that users can also leverage. And that is one thing that we're working on, is to provide the end users, the research community, with the ability to leverage the fact that those programmable resources, programmable SmartNICs, they're behind programmable resources that are also programmable in the same ecosystem. So theoretically, your P4 is going to look almost identical on both devices, whether it's on the switch or whether it's on the edge with the FPGAs. So like I mentioned, one thing we're working on is providing a pipeline for users to leverage that programmability. And for those of you who are interested in Tofinos and Barefoot and P4 programmability, roughly 15 days ago, Intel has open sourced all of their P4 software, so that is worth checking out. Another resource that is available is the ConnectX 6 network cards. So plenty of the nodes on Nautilus at NRP are ConnectX 6 cards. Those are connected to the internet and to their switches by ConnectX 6 cards. In most cases, one port is plugged in. That port is used for deployment. That port provides the node with the internet and with the connection, the deployment connection. The other port is available and can be used for research. So it can be, you can use the other port on the same card. That can be used as an interface that can be used in research. In applications like, for example, what Justas talked about, so VPP and FreeRouter and DPDK, these are all applications that can be loaded on those ConnectX cards and used for SmartNIC research. And the other thing to mention here is that there are 7 Bluefield 2 SmartNICs on the cluster that are available. They're on 7 Bluefield nodes. Each node has 1 card. And those cards come with enable Doka flow pipelines that provide packet processing pipelines similar to what P4 has to offer. And these are all resources that users can leverage on Nautilus, and I'm just going to talk about how we leverage these resources. So to be able to conduct network experiments on Nautilus that leverage those SmartNICs, first of all, you have to, the main component here, the essence of the success of these experiments is having ESnet sense. So we only have a big thank you to give to the ESnet folks for providing the ESnet sense framework and the sense orchestrator to have that path provisioning that allows us to take 2 ports on 2 different nodes and plumb the traffic, establish L2 and L2 path between those 2 interfaces, regardless of geography, regardless of where they're situated, and allowing us to dynamically configure a VLAN tag or a set of VLANs between those interfaces. And this is one thing that we leveraged in our experiment with FPGAs. And another thing is Multus, which is a tool, the Kubernetes tool that allows us to attach those interfaces. So sense, provisions, VLAN interfaces, Multus attaches them to the pod. And then we can just start our own pods like we normally do, and they'll have those interfaces from the SmartNIC up and ready for experimentation. And the way we used these set of tools is that we conducted a microSID SRv6 segment routing experiment that uses the FPGAs we have on Nautilus and some of the FPGAs that are available on the FABRIC testbed. So for those of you who are not familiar with FABRIC, it's a federated research testbed that offers plenty of networking resources. And FABRIC is also similar to Nautilus, situated across multiple campuses across the United States. And at each FABRIC site, there is a U280 Xilinx FPGA, very similar to the U55Cs that we have. You can see them in the pictures over there. They're programmable in the exact same ESnet workflow that we talked about extensively. And our experiment was basically writing our segment routing IPv6 logic in P4 and conducting an experiment where we formed a loop that goes from FABRIC, loops through the FPGAs on Nautilus at SDSC, and then goes back to FABRIC. And we used the UCSD FABRIC site. We also tried the same experiment with the other sites like Starlight, so going through UCSD to Starlight as well. And this could not have been possible without us being able to use ESnet sense. So we conducted our experiment. Now we have to think about users. So the research community, we have to be able to provide a framework for users to be able to leverage those SmartNICs. So we have the sensor orchestrator. What we did is we built an operator on top of it. So sort of a wrapper that allows users to establish those paths without having to deal with the orchestrator, without having to sort of familiarize yourself with the system. So you can pick, for example, node-2-6 is an NRP node. It's right here at SDSC. This interface on it, this is the second port of a ConnectX-6 card. And node-2-7 is another ConnectX-6 port. And this is just a simple YAML example that allows users on the end to establish that path. And from there, all they have to do is just plumb their traffic, and they conduct a similar experiment. Now, very briefly, going from here to the future, this allows us to conduct more meaningful experiments, especially when it comes to both network-driven AI research and AI-driven network research, and the mix and match. So, for example, we have examples of nodes where A100 GPUs and Xilinx Alveo FPGAs are situated on the same node. Theoretically, you can start your own pods and have them affect each other. So the GPU will control the SmartNICs control plane, and then you can have machine learning on your network data, and you can have your network in a Kubernetes-aware fashion also drive your AI research as well. So that is what we're looking for and hoping for in the future, since we have the tools to do that, and everybody that uses Nautilus has the tools. It's just so that we have to get out there and start creating it.
Thank you, Mohammad. Yeah, no, I just want to leave a little bit of time for questions. So I want to thank all the speakers. So yeah, maybe if audience has questions, let me just give a kind of a quick summary of where I think how this all fits together and why I think it's important for this community. When we talk about integrating these network services with these very powerful edge resources like NRP, and there's others, and then going up the stack and integrating the services from the application, this is very powerful, because now we're really talking about from the application down to these powerful edge systems, which are now getting widely distributed in a very distributed manner, and then all the network services we have. So we're trying to glue all that together, from the application down to the powerful edge systems, all of the network services. And I think SmartNICs are going to be a very important glue to allow it to happen, both from monitoring, from performance guarantees, from just awareness, from security. So I think this is a very important topic, this whole integration to SmartNICs. So I'm going to ask the audience if you have any questions for the panelists on these topics, please let me know. Or go ahead and ask the questions. If not, I have a few questions on my own, but I'm going to, let's see if the audience has some.
I have a question for Mohammad. The 7 and Bluefield, where are they located in the world physically?
So there are the Packwave iGrok nodes. So I know one of them is at SDSC, and one of them is over at Starlight, and one of them is in Guam. I'm just not sure about the other 4.
So
but
basically, you
they're
have
spread
a
out.
worldwide distributed network of Bluefield SmartNICs
Yeah.
that people can play with.
Yeah.
There we go. Seattle, Chicago, New York. Basically covers all corners of the U.S. North, south, northwest, southwest, northeast, southeast, and then Guam. Nothing southeast, just northeast.
Actually, so one thing to mention that I forgot to even brush over is that we have 3 Xilinx SN1000 FPGAs, and one of them, those are also deployed on the cluster. One of them is at the Ampath in Florida, so there is something on the southeast.
Okay, cool. Thank you.
Yeah, I have a question. So if we look at the SmartNIC technologies we have now, we have Connect X6s, which have like some hardware offload for some security. We have DPDK in terms of being able to pull things from the network up in the user space and do things like VPP, where we can parallelize the processing of networking stack, which greatly improves performance. Now we're going to have these Bluefields where we can actually run things, run codes, containers inside the NIC cards. We have, Mohammad, what you're doing with FPGAs. So if I look at all those tool sets, and maybe I'll start with Mohammad, when you look at the work you're doing with FPGAs, and I know you're focused on like P4 front ends on top of FPGAs, but they're like ESNet's high touch is more monitoring. Where do you see like the most important feature set? Is it in the networking architecture? Is it in the analysis and telemetry of application data? Is it all those things? Are they completely different use cases, or can they be integrated? How do you see the whole FPGA technology being applied to the different use cases?
I think, and this is just my personal perspective, is that since we have the FPGAs, we have the resources, and all of them are of very high importance, so there is no prioritization to one workflow or one use case over the other. I see them all sort of, if the right term is converging, with machine learning as well enabled, because we have been leveraging the FPGAs, we have been leveraging the SmartNICs, but we have been leveraging the GPUs in a sort of a separated fashion, and SmartNICs allow us to leverage their coexistence with the GPUs to add in the machine learning element to all sorts of areas in the network.
Okay, great. Let's see, Julio.
Thanks. Great talks. Really happy to see a lot of the work that's being done here with the SmartNICs, as well as the use of telemetry and the in-network AI acceleration. You know, we're moving in the same direction with our projects. But one of the things that challenges me, and I wanted to pose this to the panel, is how do we message this as a community to the major facilities? I mean, I'm finding that they're not aware of what we're doing. Maybe the LHC community is. I'm doing a lot of work to expose this to the astronomy community, but I think we have to do a lot more for them to really benefit from these investments and these capabilities that we're putting on the network. So I'm interested in your thoughts about this. How, you know, what are you guys thinking about doing this? How do you present this? We're fortunate that we have projects like NRP and OSG and PATH and NDP and all of these as it's going up the stack. But are we making progress reaching out to the scientists, to the major facilities, for them to benefit from this?
Well, the Global Research Platform was set up to do exactly that. And so that's one form. And
I couldn't hear the answer.
Jerry, you might want to use a microphone.
Testing. Yeah, the global research platform, but also specialized test beds and events such as supercomputing, where there's something called the NREs, which I know you're familiar with, the Network Research Exhibitions. That's a nice way of communicating. And now OFC has also OFCnet. There's also Supercomputing Asia, which stages every 2 years their Data Mover Challenge, which is also a way of communicating. I think that's the quick and easy. There's more difficulties. One is the fact that it's very difficult to get these capabilities into operations. The standard production network engineers resist some of these innovations. They don't want to deal with something like a DTN. Whose job is it in a NOC to deal with the DTN? That's an issue, and not quite sure how that gets resolved. But
I have a different perspective.
okay, go ahead.
I think everything that Joe said is true. I mean, these are strong demonstrations of possible capabilities for the community. But where I think the problem is, and I've dealt with this for probably 20 years or more, is engagement. For reasons, cultural reasons, which I don't understand. Even science programs that are quite able to field significant computing and storage capabilities continue to find the network, especially wide area networks, completely mysterious for reasons which I don't think are logical or necessary. So, you know, showing that these are not just, but if the science programs are to do the best they can, both in executing and also crafting future requirements, then they should engage with these capabilities, not only point to point, but system-wide, and think about the opportunities for their workflow and ultimately the opportunities for their discovery reach. Now they're not hearing, or the people in positions to hear are not familiar, but we have to find a way that the message gets across. And it might take other entities such as funding agencies to help carry the message.
Okay, thank you.
I have a totally different answer and in a totally different direction. Maybe, and I'm not sure that this pans out that way, but the universities and the colleges are under enormous pressure for cybersecurity. And the kind of things that you can do with the kind of technologies that you guys are working with is just transformational if you apply it for, let's say, cleaning up the network. I'm not sure what that would mean and how one would do that, but we now have the means in principle to get rid of all these foreign country interference crap that torture us at our universities with constant cybersecurity attacks and that lead to our administrations doing all kinds of foolish things and impose upon us. And so I'm wondering whether that's the killer app for what you're doing as you look sort of 5-10 years into the future.
Maybe I'll let the panel, I could think of some answers, but I think Justas has done a lot of work with site level control and features.
Yeah, I guess to your point, Frank, that's what we discussed with Mohammad. It's kind of, if you empower everything what we do on Sense, and let's say you have everything on NRP nodes, you can create your own overlay network. You don't need to be exposed to the outside world at all. So you have your own SD-WAN where you can control bandwidth, where you go, from which path you go, or maybe just reroute the traffic as you want.
Private, isolated network.
Yeah, that works for specific applications. That it doesn't work for. It doesn't even work for something like NRP because it's way too diverse in its customer community. I'm thinking. I think James told me this over lunch. that there's now commercial providers that just let you plug in as an entire campus, reroute through their network, and they clean it out, and nothing comes out of the end that isn't clean. I mean, I have no idea how that's supposed to work, but I think along those lines, that basically at the Scenic Pop in LA, nothing that comes out of UCSD except for via the commercial networks, but all of the research traffic goes via the Scenic Pop to first order. And so if they cleaned up our network from all the crap that we don't want to see, voila, a lot easier to live with. Is that a future that we could aspire to with the kind of technologies that you have?
I think, I'll just add a little bit to that. I think, to me, that is one of the power is when we have this computational capability in the NIC at end systems, we can do these types of, we can look at it at a very granular level for security, for characterization of applications, for development data. So I think yes, and maybe, Joe, you've done a lot of work with high-speed, SmartNICs. Yeah, and I think maybe you're more focused on monitoring than security, perhaps. Yeah.
Every single packet
Yeah.
in the network. That's
Well,
really powerful.
We know that CIOs are typically very afraid of intelligent systems because the job of securing such systems against attack, against backdoors, against code that's, has the capability of being exploited, means that supporting such systems also have a higher standard. And Joe referred to the fact that, present or previous generation network engineers are not familiar with these tasks, that if we start to field intelligent systems, then the training for the next generation of network engineers and scientists and architects working on networks also will have to step up.
Yeah, I think we're just about out of time. I don't know if we want to take Julio's question or.
Sure, last question.
Okay.
So just to answer Frank, so we're looking into this. The approach we're taking is the telemetry data. We think the telemetry data is really the key here, and with the telemetry data, we can see all the events occurring on the network. We've been using the telemetry data for capturing, detecting microbursts as well as DDoS attacks. The scrubbing that you're talking about, I think, is possible as well with this type of data. We've also started to work with machine learning models to train the models on detecting these kinds of data and to eventually get to a point where there's an automated way of stopping them or taking some kind of action so that they don't impact the resources on the network. So the key, I believe, is the telemetry. And I think you guys are on the same path with high touch as well as the telemetry data from the SmartNICs.
Thank you, panelists. Thank you, everybody.